Hello everyone, my name is Manny, and I just wanna introduce the idea of base in mathematics or in numbers. My previous video, if you have watched it or you might check it out, it's about types of numbers in mathematics. Now, I figured to kind of give the audience some type of knowledge about the base. Basically, all numbers that we use in our everyday life are numbers with base 10. Meaning, all of these numbers would be, let's say we'll take real numbers. If we think about real numbers, let's say the number 11. The number 11 is a base 10 because when we start counting, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, now we hit the 10, right? If we start from 0, let's say, when we hit the 10, we turn into a double digit. Now it becomes 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and now we go by 20, 20, 30, 40, 50, all the way. So we go, if we write in this way, we go of rows of 10. Now, for those of you that have taken computer science, they know that logical operators, true or false, go in bases of 2. Let's say, those numbers are just 0 and 1. So bases of 2, let's say we have, okay, let's take our example, 11. How do we rewrite it in terms of, let's say, in terms of 10? It's more like 1 times 10 to the 0 plus 1 times 10 to the 1. This is actually the representation of the number 11. And now, taking this in mind, we could, let's say, if we have a binary number, which is base 2, that's about 1, 1. Okay, let me put a subscript 2 just to indicate that this is base 2. So what would this number equal as in base 10? It would be a blank base 10. To resolve this, we will apply the same logic as before, as we see up here for the 11. So we'll take 1, 1 base 2 is actually equal to 1 times 2 to the 0 plus 1 times 2 to the 1, which is equal to, in our decimal or base 10, which is just 1 plus 2, which is a 3. Okay, and base 10. So we could write here. Amazing, isn't it? Now, let's say in base 10, right? How would you represent a number that's, let's say, about 393. So this number This is base 10. How would we represent it? So it will be just 3 times 10 to the 0 plus 9 times 10 to the 1 plus another 3 times 10 to the second power. So it goes like this. This is equal to 393 precisely. Now if we take another number in base 2 and we call it 101111, that looks like an interesting number. That's in as base 2. Let's convert it into base 10. What would the number equal to? So we start with the rightmost and we go this way. The same way, if we pay attention, the same way we apply here. This 3 is actually from here, and this 9 is from here, and this other 3 is from there. So we see that we start from right to left in writing. So it's 1 times 10 to the 0 plus another 1 times 10 to the 1 plus no, this is binary. See, I was already making a big mistake. 2 to the 0, 2 to the 1, and then 1 times 2 to the 3 plus 1 times 2 to the 4. So we have the first 4 ones, and then 0 times 2 to the 5 plus 1 times 2 to the 6. If we add all of this, we'll get the number in the decimal system. DC in physics is actually, it means 10. So decimal is actually a base 10 system. So we'll get it to equal to 1 plus 2 plus 8. No, I see a mistake. So it's 2, 3, 4, and a 5. So plus 4 plus 8 plus, here it's a 0, plus 32. So we could see that it's equal to 3 plus 4 is 7 plus 8 is 15 plus 32, it's 47. That's what this number represents in decimal. Okay, so we could now basically do any system. Let's say if I have a number that's in system, let's say 4, in base 4, or let's say base 3. Let's just say base 3, and base 3 will definitely have these numbers as 0, 1, 2, and then 10, 11, 12, and then 2, 0, 2, 1, 2, 2, and then 3, 0, 3, 1, 3, 3, and then after it turns from 3, 3, it turns into 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 2, So yeah, no, basically there's no threes. It's just 0, 1, and 2. Okay, so that's base 3. Now let's say we have a number that's 1, 2, 1, 0, 1, 2. Base 3. How would we transform it back to um, decimal system? So it's really easy, just an application of applying the power. This is actually equal to, so it's 1 2 1 0 1 2, and base system 3 is equal to 2 times 3 to the 0 plus 1 times 3 to 0 and 3 to the 1 plus 0 times 3 to the 2 plus 3 times or plus 1 times 3 to the 3 plus 2 times 3 to the 4 plus 1 times 3 to the 5. So we have 6 numbers. The highest power is always n, which is the number of digits minus 1. Okay, 5. So this is equal to 2 plus 3 plus that's 0 plus 27 plus 2 times 81. It's 162 plus 3 times 81. 3 times 81 will be, let's calculate it. $243. So if we add all of these numbers, we will get the decimal representation of the number that was shown there, which is 437. And this is in base 10. That's all. Thank you for watching. I hope this video benefited you somehow in understanding how the number system works and how binary system works. Good luck with your studies. Thank you.